All right, we're going to talk about quadratic systems. So quadratic systems are just a quadratic equation and another equation. It could be linear, it could be quadratic, and we're just looking at the points of intersection. So we're going to kind of look at just linear and quadratic. So I could have two solutions, right? That line passes through the quadratic twice. If it's two quadratics, they could intersect twice also. One solution, they're just going to touch in one point, no others, so the line does not go through, quote unquote, the inside of the parabola. And then we have no solution, so there's no points of intersection. So the first one is I'm going to come here and I'm going to actually graph these. I personally don't do a lot of graphing. I will typically look at solving them algebraically. But sometimes it's nice to have a graph of it and kind of see maybe an approximation of where those are going to be. And if you have a graphing calculator or some other graphing system that's going to get a little bit more precision, that's good too. So I'm going to start by graphing my line just because that's easier. So I'm going to go down to -3 and then up over 1, up over 1. So there's my linear equation, okay? Now I'm going to graph y equals x squared plus 2x minus 3. Well, the first thing I want to do is find my vertex. So that's going to be -b over 2a, and then f of -b over 2a. So I'm going to find my item here. I'm going to go -2 divided by 2 is -1. -1 plugged in, so I'm going to plot, so if I come here, I get -1, I plug in -1, I get -4, and so now I'm going to plug in -1, -4 here. There's my vertex, should be about here. If I look here, this is going to x plus 3 and x minus 1. So I know here that I have at +1 I'm at 0 and at -3 I'm at 0. So I kind of come down here and I come up here. And so my points of intersection are here and here. Well, you can see that I have a little bit of error here. So I know that this is -3 and -3. So I know 0, -3 is my point of intersection because that's my y-intercept. And then it looks like I'm right at my vertex. So -1, -4, which that satisfies this one. So there's my 2 points of intersection. Now you can kind of see why I typically won't do a lot of graphing. Because if I'm graphing by hand, I end up incurring a lot of error. So the next one I'm going to do algebraically. And for the most part, I'm going to do the rest of them algebraically. So what I'm going to do is I'm going to set this equal to each other. Okay? I'll leave a little space here so when I have it. So most people don't like working with -x squareds. So that's okay. Just add it to the other side. So x squared plus x minus 6, I get 0 equals x squared plus 2x minus 3. Nice thing is this actually factors. It's the exact same one up here. So I get x plus 3, x minus 1. So now I know my x values are -3 and +1. Now that only tells me my x values. To find my points of intersection, I have to go through and plug those back in to one of my equations. Well, I'm going to plug it into the linear equation because that one's a little easier. So -3 plus 3 is 0. 1 plus 3 is 4. There's my 2 points of intersection. Okay, so that's the algebraic side of it. Now, if I have two quadratics that I want to find their points of intersection, what I'm going to do is I'm going to set those quadratics equal to each other. X squared plus 7x plus 12. equals negative x squared minus x plus 12. I'm going to take the right side, I'm going to move it over to the left. X plus x squared plus x minus 12 plus x squared plus x minus 12. So on the right, I now have 0. I have 2x squared plus 8x. Notice those cancel out. I now look at greatest common factor, which is 2x, x plus 4. I'm going to set each of these equal to 0. So 2x equals 0 or x equals 0. X plus 4 equals 0 or x equals negative 4. So now I need to find my points of intersection. So I'm going to take and plug in 0. Well, if I plug in 0, that one's easy. Everything goes away. I end up with 12. Now, if I plug in negative 4, it doesn't matter which equation I plug it into. So I'm going to go negative 4 squared plus 7 times negative 4 plus 12. So this gives me 16 minus 28 plus 12, which gives me 0. So my point of intersection is 0, 12, and negative 4 is 0. Okay. The last one we're going to do is what happens if we have inequalities. Well, inequalities we do have to graph. And so what I'm going to do is I'm going to rewrite this one in black. So y is greater than x squared plus 3. That way I can have two colors here, and you can kind of see which one is which. So I'm going to go ahead and draw up my coordinate plane. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to graph my black one first. So I have x squared plus 3. I know my vertex is at 0 because I don't have a b. So my vertex is at 0, 3. All right. If I don't know the two other points, that's fine. I can pick one unit over from my vertex. I'm going to pick 1. 1 squared is 1. Plus 3 is 4. So I end up looking like this. Now, I need to decide if I'm going to use a solid or a dashed boundary on that. So what I'm going to do is I look here, it's greater than, so that's dashed. And I'm shading above. So I'm shading this part right here. I'm going to put it in really light, so that way I can kind of color in that other piece later. Now I'm going to graph the red one. Okay, this one's not quite as easy to graph. It's not too bad. Remember, my vertex is negative b over 2a, comma, f of negative b over 2a. So negative b, that gives me negative 4 over 2 times negative 1, which is going to give me 4 over negative 2, which is negative 2. Okay, so I'm going to plot in negative 2. So negative 2 squared, so I have negative 2 squared minus 4 times negative 2 plus 3. So this gives me negative 4 plus 8 plus 3, which is going to give me 7. So there's my vertex. So, oops, right here. Negative 2, 7, negative 2, 1, 2, 3, 4, 5, 6, 7. Okay. I need to get my graph in there, so I need to go, I could go 1 to the right, 1 to the left, I could go 2. So if I plug in negative 1 here, I get negative 1 plus 4 is 3. 3 plus 3 is 6. So negative 1 I have 6. That means negative 3 I have 6. And now there's my 3 points to draw this in. Now I need to decide if it's a solid or a dash boundary. It has an equal sign, so it's solid. Okay, so there's my piece. It says it's less than, so I'm going to shade in the bottom part. And then my common piece, I'm going to put it here in blue, is the piece that's between them. So it's that piece right there is my common piece in that systems of inequalities. Okay, so that's kind of a quick one on systems of quadratics. If it's equality and we're finding those points of intersection, I personally would use algebra. I'd set them equal and solve it. Graphing gets you a good idea, but there's a lot of inherent error if you're using a hand-drawn graph.